Hey guys, welcome back to another video. So in today's video, we're going to discuss a question that came in the JEE Advanced exam in 2017. So here's this question right here. It's about optics. So let's read the question. A monochromatic light is traveling in a medium of refractive index n is equal to 1.6. It enters a stack of glass layers from the bottom side at an angle of theta is 30 degrees. The interfaces of the glass layers are parallel to each other. The refractive indices of different glass layers are monotonically decreasing as nm is equal to n minus m times delta n, where nm is the refractive index of the nth layer and delta n is 0.1. The ray is refracted out parallel to the interface between the m-1 and m slabs from the right side of the stack. What is the value of m? Okay, so we read the question. Let me just highlight whatever delta n is, and yeah. So in the thing that we read, that whole paragraph that I read, the things that I've highlighted are the most important parts here. Everything else is pretty self-explanatory by looking at the diagram or whatever. So let's start. So what we know first is the refractive index of this. So this is 1.6. And every time, or in each of these, the refractive index decreases by 0.1. So from the question, we actually have n suffix m is equal to n minus m times delta n. Now this could be written as 1.6 minus m, 0.1 m. And that's equal to this. Okay, so now we've got that. So here, we could just replace these pretty easily. So this would be 1.6 minus 0.1, that's 1.5. This is 1.4, 1.3, and so on. Now, what they told us here, let me highlight it. The ray is refracted out parallel to the interface between the m-1 and nth slabs. So we're talking about this section right here. So what we're going to do is we have to find m. Now if it comes parallel to the interface, let's just draw some of these normals here. Like for example here, they drew the normal. Here, that's another normal here, and here. So similarly, we're going to draw a normal here as well. And by the way, this angle right here, what they gave us, 30. So this angle is 30 degrees. And this angle is 90 degrees. So the final refracted angle is 90 degrees. As it emerges out. So yeah, now what we're going to do, we're going to follow a simple, we're going to test something out and then we can finally apply it fully. Now we know Snell's law, right? Snell's law. And this is in refraction. So we have mu1 sine I is equal to mu2 sine r, where I is the angle of incidence and R is the angle of refraction. Similarly, mu1 is the refractive index of the first substance or layer, and mu2 is the refractive index of the second substance or layer. So if we were to talk about just this area, we're just talking about this area where the first ray is entering, or actually where the ray is just entering the, the stack of glass, we can come up with an expression, and that is n times sine theta is equal to n1 times sine something else. So I'm going to call this angle right here as phi, let's say. So n sine phi. Now we know n is actually 1.6, and we know theta, so this is 1.6 times sine 30, and that is equal to, we know that n1 is 1.5, so 1.5 sine phi. Now doing this, we can find sine phi, and we could, we can find phi as well, the angle of refraction in the first slab. And we could continuously do this until the angle that we found is 90 degrees. So we can continuously use this and, do this process over and over again until we get the angle of refraction as 90 degrees. However, that's an absolute waste of time. Instead, what we can do, now, we'll think about this. So if I was to continue, so we'll do n1 sine phi is equal to, so this is going into this like this, and okay, let's zoom this up a little bit, and I'll use a different color so that we can see. If it's going in like this and it is refracting, this would be our angle of refraction. Once again, it'll be the same thing as phi. So this is phi. And this here is what we're trying to find. Now, similarly, you would do that over and over again. So if we were to substitute these in the formula, we would get n2 sine, I named that as a question mark, and we can find this question mark. Now, if we keep going on, this n2 sine question mark would be equal to n3 times sine alpha, let's say. And this occurs so on. So what we can directly write is this instead. So we can directly, and by the way, this is equal to n sine theta. So notice how we can equate n sine theta to this, or directly to this, or directly to that. So similarly, what I'm trying to say is that we can directly equate n sine theta to nm sine 90 degrees. I don't think it's nm actually. Oh yeah, it is nm. So we can directly equate it like this by using that. So we know that n is 1.6, and we know sine 30 degrees is half. And we need to find, we need to find nm, so we'll just leave that. And sine 90 is 1. So 1.6 times a half is 0.8, and this is equal to nm. So we got this. Now we have to plug it in to this right here. This formula that this expression that we wrote. And what we're trying to find is m. So we know that nm is equal to 1.6 minus 0.1 m. And we also know that nm is equal to 0.8. That's equal to 1.6 minus 0.1 m. Bringing this the other side, we get negative 0.8 is equal to negative 0.1 m. And finally, we would get m is equal to 8. So that's our answer right here. M is equal to 8. So that's that question from the JEE Advanced examination from the physics paper in 2017.